Hi all, welcome to my channel IT Learner Zone. This is Professor Zeba Roslet and I'll be covering the topic of active DBMS in this lecture. The topic of discussion in this lecture would be the preliminary aspects, the architectural approaches, the language for rule specification of active DBMS and the execution model of active DBMS. So let's start with today's topic and we have a broad discussion on active DBMS. So let us discuss with active DBMS in today's lecture session. So initially we will discuss on what is passive DBMS and what is active DBMS. So conventional DBMS are passive, as you could see that they execute the operation only upon the explicit request. Often, however, there is a need for some reactive capabilities. The DBMS can autonomously react to some events and execute specified operation. So we refer to active DBMS to DBMS for which we can specify some active rules, also which is called as triggers. So looking at this example, here we have an automated management system of a store in which you could see the available quantity of a product X is given. So if the quantity of the product goes below 4, then 100 of such item needs to be ordered. So looking at this image, you could see if there is a sale of 2 item of product X, immediately the quantity goes below 4, and now you could see we have to order 100 item of product X. So this cannot be done in conventional DBMS all by itself. It is not automated. We have to do it manually. Whereas in active DBMS, you could see if the quantity is less than or equal to 4, then you can order 100 items. And this can be automated all by yourself or by the DBMS. You can do it, and the database can automatically go for ordering 100 item immediately when the condition is being satisfied. So this is just one example of how this active DBMS or active rule can be set to react to certain condition. There can be other examples where you could be using active DBMS. So one such example can be alerting, like if certain situation do arises, then immediately an alert message can be popped up. It can be used for auditing. If there is a security breach, then immediately you can specify the actions to be taken in security system. There can be some statistic values which you can set, like on reaching some certain threshold value you can react to certain events. Therein you can set it on views. So these are some of the examples of how you can use active DBMS, or you can place active rules to react to certain conditions and events. So there are different approaches to satisfy such applications which requires automatic executions of actions. Now there are broad applications where this active DBMS can be implemented. So one such is production control. Like say for example, you can set power plant, you can go for maintenance task where you can set an active DBMS for inventory control system. You can set for financial application where stock and bond trading are the preliminary aspect of any financial system. Network management, it can be implemented with air traffic control system. It can be with program trading. It can be with computer integrated manufacturing system. So these are the broad applications where active DBMS can be set for reacting to certain events and conditions. So when you talk about architectural approach of passive DBMS, you require two types of applications to control the system. So one is application which will update the system, and second is an application which will have a periodic polling to the system to check and reply. So in order to determine the optimal polling frequency, we need to constantly keep a check on passive DBMS, which is like if you are doing it too frequent, then there is a inefficiency in the system. Or if you're not doing too frequent, then what happens is there may be certain reactions which you may be missing out, and the reaction may be lost in that case. So these are some of the disadvantage of a passive DBMS. As you could see, it compromises with code modularity and reusability. So if a monitor condition do change, then the application has to be changed. So it is like you are playing around with reusability concept here. And the reaction logic is external to the DBMS. As you could see, it is not inbuilt with passive DBMS. So this are some of the advantages of passive DBMS. So what can be done is you can go for active DBMS. So active DBMS is where you can set up your queries, you can set up your updates, you can also specify your external event, and you can also specify the situation which needs to be monitored and the reactions which need to be taken care by an active DBMS. So it is following an integrated approach to the system. So you can summarize an active database system as a system which is having an additional capability of a passive database system, and you could specify that there is some situation which needs to be monitored, and you can invoke the specific reaction whenever a situation occurs occurs in the program, or it can be related to some database operations. So active DBMS structure has database operation, it has abstract events, it has time events. Everything is integrated into a database. The production rules are defined, and once the ECA rules are defined based on certain triggering events and condition, you could see the results are getting generated. So we can summarize it's a situation, or we can summarize active DBMS as a database where in which some operations which are automatically executed once a given situation arises. So it can be specified what situation it be. It is like certain events, it can be some specific condition or some certain state transitions which while detected can be invoked. So active rule, or you can call it as trigger, is a language construct for defining the system reactions. So here we could see the specification of an active rule, the ECA paradigm. So in order to define a proper trigger definition, it has to be it has to be defined in event condition action format. Event, like if it arises, it activates the trigger. Condition, if the condition is satisfied, then the trigger action is executed. An action is like if a sequence of operation, it is defined as a sequence of operations that can modify the database, and such sequence is executed only if the condition is getting satisfied. So here there are the most here it's given in the form of a it's given in the form of trigger, like on event, if condition, then action. So if the event arises, the condition is evaluated. If the condition is satisfied, then the action is executed. So the active rule paradigm basically originates from the notion of production rule of an AI system. So here the production rule do not typically specify any event. They have the form of condition and action. If condition, then action in an AI system. Whereas in our case, it is event, condition, and then action. So as you could see in the screen, it is like on event has occurred, and if certain condition holds, then you can define it as a situation. Then you specify execute action. So action defines yours as a reaction. So this is the general structure of event, condition, action rules. Now there can be example, like say for example, I want to look for the complaint list, and if the complaint list is greater than 0.1, and I would multiply it with reservation, and if this condition is getting satisfied, then I'm going to reduce the price of that particular flight details. So this is one of the example of event, condition, action rules. Now, why it is useful to have events in rule? Because you could see every time when I'm executing a condition, it is going to be expensive in terms of efficiency, in terms of evaluating it throughout the DBMS. Whereas when you talk about detecting an event, it is less complex than executing a condition. So when you are particularly executing it on a very large DBMS, then you could see condition can be too expensive. So one can specify different action for different level, and the same conditions can be applied to all. So we will go for a discussion on what is event, condition, and action here. So what is an event? An event is something which happens, which is of interest, and which can be mapped onto some time instant. So what are the types of event? It can be a data modification event, like someone is inserting, deleting, or modifying the database. It can be a data access, like you when you are using your select statement to query your tables. It can be a DBMS operation, like login of the user, transaction, or someone is doing with authorization. So this can be the event. It can be a temporal event, which is related to the date and time. It can be application defined event, like when the room temperature is high or when it is low. This can be a different set of events which you can define in event. So the semantic of ECA rule based on knowledge model is defined as on event has occurred. Now what are the events which are defined? You could see on the right hand side. The events are defined like, say for example, it can be on the begin of or at the end of DBMS operation, like on, after, or before, or it can be on begin or end of the DBMS, like on beginning of transaction or end of transaction, or it can be on temporal events, like on particular date and time, on particular event, or every day you can set up, or it can be on some abstract event which you need to define on specific program start, or when someone raises certain program start, or on program start. This can be defined as event. So this is all on events. And events, you could see here, is like when you define an event rules based on the events, you need to specify whether it has to be activated before or after an event. So possible combination for events can also be defined, like logical operators can be used. You can define the rules in a sequence, like a trigger is activated only if two or more event arises, and that too in some specific order. Or it can be in the form of temporal composition, like a trigger is activated when event 2 arises 5 seconds after event 1. So this can also be the way in which composite events can be defined. So here you could see the composite events can be like combination of using relational operation, like you can use OR operation, you can use it in ordered sequence, you can just use AND operator to combine two events, you can use negation operator, you can also define times. So this is how composite events can be generated. So going for the next topic over here is conditions. So along when you specify active rules, you need to define condition. So what is a condition? A condition is an additional check that needs to be executed when the trigger is evaluated and before the action is executed. So here the where clause of SQL statement is where you could see has the evaluation part. The query, the condition is true if and only if the query returns the empty set, then a possible meaning needs to be defined. And application procedure is to call a procedure in order to react. So knowledge model of ECA rule, here you could see condition. So predicate is basically you could see condition is defined with where clause which executes on your database, and action needs to be specified on your program which includes database operation or notification to the users. So the observation is over here is that the condition may always refer to the past state. It can be either new or old value of an attribute or to the system variable. It can be a parameter passing between the condition and action, and if there is no condition defined, then the condition is always assumed to be true. So this is how the observation of condition is defined. Then comes action. So what is an action? An action is a sequence of operation that is executed when its trigger is considered and the trigger condition is true. So the types of actions can be like database modification, like you do insertion or deletion or updation. It can be in the form of data access where you query certain tables. It can be certain commands like data definition, transaction action, commit, rollback, grant, revoke of operation, an application procedure, or to call to a procedure based on certain condition. So action specification is a part of a production rule which specifies the operation which needs to be performed when an rule is triggered and its condition is satisfied. So here is an example, like say for example, define rule favorite new employees on insert to employee. So the event is given like on inserting, then delete employee where employee name is equal to employee name. So this way you can define a rule. Now, there are some additional features which need to be defined with active rules. So the commands for rule management allows you to create, modify, drop rules, or to enable or disable rules. So rule priority also needs to be defined here. When certain rules or when several rules are activated by the same event, then the policy need to be devised to determine which rule to be processed from this set of activated rule. So the choice needs to be based on the priority. The priority can be a relative priority or it can be in the form of absolute priority. Relative priority is between the pairs of rule, which is more flexible, whereas absolute priority, it requires the priorities to be updated as the rules are added to it. So one of the example of rule implementation is given here, which is an ingress traffic which is flowing inside a DBMS. So here you could see it is clearly defined which part is the event, which part is the condition, which part is the action. So create rule complaint check. So complaint check, here you could see so create rule complaint check name. So complaint check is the name of the event. After insert of complaint, this is your event. Then what is an action? Execute procedure insert complaint. M destination is new destination. So here you could see here the action part needs to be defined since action is a procedure here. So you can define create procedure, insert complaint. So insert complaint has you have to define M destination. You need to check complaint. You need to check book, and you have another parameter of message. So this is the procedure you have defined in the place of action. Now you will define the rule entirely in broad description. Like say for example, I am counting the number of complaints from certain table called complaints. Then I'm counting checkbook, and that is I'm doing it with the table reservation, and I'm going to check for a certain condition. Like say for example, if check complaint is greater than checkbook divided by 10, then so now the then condition is the action part, which is giving me an error message, and it says that the minimum that has a minimum of complaints exceeded. So it is giving me an error, the message is passed. Immediately I am inserting the destination log value, and I am updating the destination like set price is equal to price into 3/4, where name is equal to M destination. So the scenario is like I am ordering for a certain tour, and if certain tour of certain destination is receiving lot of complaints, then based on that complaints, you could see the price of that particular tour is reduced. So that is how the entire rule implementation is done on this particular scenario. So you could see as soon as the complaint reaches to certain point, to certain extent, and based on the condition like check complaint greater than checkbook divided by 10, if it is reaching to this particular scenario, automatically the price of that destination has been reduced by 3/4. So this rule can be automatically invoked on your DBMS on the certain tables, and you could see the price can be updated as per the flexibility to give offer to the customers. So main activities in an active DBMS is to detect an event and activate the corresponding rules. Then you can select and execute the activated rule, which is also called as active or reactive process. So these are the two activities which can be executed concurrently. So the possible model is like based on two activities, like say for example, while true, do, detect the event, activate the rule associated with the detected event, and end while. It can be in the reactive process form where there is still active rules do. It can be in the uh, reactive process form while there are still some active rules do. You need to select a rule for consideration that comes under selection. You have to evaluate the condition of R, that is evaluation, and if the condition of R is true, then execute the action of R and if. So this is how you could define the reactive process. In the previous case, you could see we have just defined only one set of activity need to be performed. Here in this activity 2, we are performing two different activities together: selection, evaluation, and execution. So overall execution model of an active DBMS is like from the source, you could see event is detected from DBMS. You need to verify the event, determine the rule body and its instantiation, that is triggering. Then once triggered, you have to determine the execution order for rules, and then you need to go for activated rules, which will go for condition evaluation, and then it will go for execution of rules. So execution model over here refers to the reactive process. So granularity of reactive process defines that how frequently you need to do this activation for a reactive process. So the common granularities, which is defined as like always, as soon as the event arises based on temporal event, or after each single operation on a database, do we need to specify, or after the execution of an entire database, after the execution of the entire set of tuples, or at the transaction boundaries, like that is before the start of commit operation, or after the execution of a set of commands or activation specified by the applications. So there are two modes in which it can be done, as one is instance oriented or another one is set oriented. Instance oriented is like the activated rule is executed for each element of database, which activates the rule and verifies the condition. Or it can be set oriented where the activated rule is executed only once for the set of such elements. So these two modes may result in different state of a relation. So we will look for an example here. Like say for example, I want to execute an action which need to be taken inside a tuple. Like I want to insert an employees relation. So when I'm inserting a record in employee relation, we could see here the rule execution example given, say for event like inserting a tuple in employees. Condition can be the inserted tuples are not already in the table, so it is already verified. Action is like replace the value of salary attribute of the inserted tuple with the average value plus 5 of the salary attributed, which is computed on all the tuples of the employee relation. So there are two way of executing it. Either I can go for set oriented execution or I can go for instance oriented execution. If I go for set oriented execution, then R is executed one time for all the tuples. So all inserted employees will have the same value for the salary attribute here, or R can be executed one time for each tuple. So when this is executed one time for each tuple, you could see that every inserted employees will have different values for the salary attribute. So how to define a rule from a set of activated rule? So it can be arbitrarily random, or it can be based on some priorities, like when the values are defined in absolute and relative quantities, or it can be based on some statistical properties when the rule has been created, or it can be based on some dynamic properties, the most recently activated rule, or it can be based on execution of a single rule. You can set it on like alternate to setting it on a single rule. You can set it on a conditions of several rule, like say for example, when several rules are defined, then there you need to define which events has to be activated and how the event has to be executed concurrently. So what is the criteria here which it defines the execution model? So criteria defines the relationship between the transaction that generates the event and the rule processing. So they establish two relationship here: event condition, condition and action. So what is the possible coupling mode when it comes to applying to even condition or a condition action rule? So the coupling modes are of three here types here: immediate, deferred or separated. Immediate is immediately when the event is generated in the same transaction. Deferred is when the transaction commits. So you could see when there is an integrity constraint, you can define, or during an execution, a transaction could violate a constraint, but before the commit, it could restore to a consistent state, or it can be in a form of separated state, like in a new transaction. Such transactions can be defined as independent or dependent from the commit of the original transaction. So these are the different coupling modes, which is the part of execution model. So what happens is that when this execution model is defined, there is a problem of termination. The reactive process sometimes may not terminate, means there might be infinite activation of such rules. So what could be the possible solution? You can leave to your database designer to define the tasks for designing such rules in such a way that it may execute its termination at the end of certain task. You can limit the number of rules which can be activated at any specific time, or you can define some syntactic restriction on rule, like a rule cannot activate each other. The rule can activate each other as long as there are no cycles, or you can define the rules may have cycles, but it is guaranteed that the condition of some rules inside of certain cycles should eventually become false at certain point of time. So this can be the certain solution for terminating the rules. So there can be another execution model which can solve this problem. So one is the transition table. So what are transition table? These are tables which allows you one to refer to the set of tuples which has recently been inserted, deleted or modified. So whenever someone is making any changes to the DBMS tables, immediately that all records are stored in a separate table which is called transition table. So you could get a detail of all the modified tuples of such tables. So in this case, the modified tuples of such tables have one records of values before the update, whereas the other record the values that is having a updated value. So in such table you can be it can be used so such tables can be used for evaluating the condition or rule, and you can also perform the execution of action of rule. So this way, when you do it on transition table, this improves the efficiency. It will also limit the evaluation of rule condition to the tuples in the transition table. So it becomes a safer option for executing your active rules on a active DBMS. So this is an overview of active DBMS. We have seen a broad category of discussion of the various topic of active DBMS, and this is mostly implemented on broad categories of application where we need to automate certain tasks where your database can actively react to certain events and conditions. The reference uh, for this particular material can be found on Elamersi Nawate book, Fundamentals of DBMS. You can also go for DBMS book of Gracia Molina, Ullman and Vidom. So thanks for joining for this lecture session.